Hello. In this video, we will cover section 7.1, which is on an introduction to surveys. Let's start off with some terminology. A population is a group of objects or people we wish to study. This could include everything from people, such as US citizens, to inanimate objects, such as houses, or even information like the contents of text messages. A parameter is a numerical value that characterizes some aspect of the object of study. This could include the percent of people who will vote, the mean price for houses, or the percent of ease that are in text messages. Two popular parameters are the mean of the population and the population proportion or percent. This chapter is focused on proportions or percents. If a population is small, then we can collect information on every member of the population. This is called performing a census. If a population is large, then we collect information on a subset of the population. This is a sample. The subset is called a sample of the population. If you put those two together with the previous page, what we can say is if we perform a census, then we will collect information from every member of the population, and we use that information to determine the parameter directly. That's unusual. More likely, we will collect samples and use the results from the sample to estimate the parameter for the population. A statistic is a numerical characteristic for the sample of data. This is the equivalent of the parameter for the sample. We use statistics to estimate parameters. Because of that, statistics are sometimes called estimators or estimates. Statistical inference is the science of drawing conclusions about a population on the basis of observing a small subset or sample of the population. That is what we're going to be doing over the next few chapters. Let's look at some examples for terminology. Suppose the goal is to find the percent of registered voters who intend to vote in the upcoming election. The terminology would be as follows. All right, so the population is going to be the big thing. So we're interested in the percent of all registered voters who intend to vote. So the population is all registered voters. The thing that we're interested in about them is the parameters. We're interested in the percent of all those registered voters who plan to vote. All right. And then as far as the sample, so since the population is large, what we're going to do is we're going to sample all of those registered voters. We're going to do a survey. We're going to talk to some of them. And then the percent of the sample who plan to vote, that's the statistic or the estimate. Let's look at another example. All right, in February 2014, Pew Research Center surveyed 1,428 cell phone users in the United States who were married or in a committed partnership. The survey found that 25% of cell phone owners felt that their spouse or partner was distracted by her or his cell phone when they were together. So we want to go through and define the terminology. So what are we interested in? We're interested in cell phone users. We're interested in figuring out what percent of cell phone users felt that their spouse or partner was distracted by his or her cell phone. Okay, and so the population is the big thing. It's the everything. And so that's going to be all of the cell phone users. All right, the parameter is the thing that we're interested in about it. So that's the percent who felt their partner was distracted by cell phone use. Now the sample is going to be the portion of the population that we're going to use because we can't contact all of the cell phone users. It's just not realistic. So we're going to go through and we're going to take a subset of that. That's the 1,428 individuals who we contact to ask them about their how their partner felt about cell phone use. That's the sample. And then the result of that, when we go through and contact those individuals and ask them whether their partner was distracted or not, that's the 25%. That is the statistic. Okay. Now the common pattern, there's a common pattern between these, and that is that the population and the parameter are unknown. So the population is this amorphous big thing. All right. So we don't actually know all of the individuals that are in this population. It's all of the cell phone users. It's all of the all of the registered voters, and then and so that's not known. We don't know every member of the population. It's this amorphous thing. And then the parameter is the thing that we are interested in about them, and we don't know that either. That's what we're trying to figure out. That's what we're trying to estimate. Okay, our goal is to go through and come up with some value for that. So we don't know everyone who's in the population. We don't know, what their, this specific, this thing that we're interested in finding out about them. We don't know those. To figure out those, to go through and come up with some estimates for those, what we do is we go through, and that's the known stuff. We go through and we take a sample, we take, 1,400 people, and then we talk to those 1,400 people and we get information from them. And so we know we know the 1,400 people. We've got a list of them, so we know that, and then we ask each one of them directly what information we're interested in, like either about registered voters, or about whether they're gonna vote or not, or what their cell phone, their partner cell phone use is like, and so those two things are both known. The sample, we know that, we know the 1,400 people, and we know their answer to our survey question. All right, and so the small thing is known, the big thing is not known. And we use the small thing that is known to estimate the big thing that is unknown. All right, and we've got notation for these. So the notation that you're going to see throughout the next couple of chapters, for the sample mean, we use X bar. For the sample proportion, we use p hat. So this chapter is going to be focused on proportions. So we're going to be looking at the second one, but in a future chapter, we will look at means. All right, so the sample mean, X bar, sample proportion, p hat. When we go through and define the population mean, we use a symbol for that. We use the Greek letter mu. And when we are discussing the population proportion and we want to represent that in some way, we use just p itself. All right, so for proportions, we've got p hat and p, and for means, we've got X bar and mu. Let's look at a notation example. So the city of Los Angeles provides open source data on response times for emergency vehicles. A random sample of 1,000 rows from their open source data has a mean response time of 8.25 minutes, and the proportion of vehicles that were ambulances in those 1,000 rows was 0.328. And it says, what is the appropriate notation to use for the information provided? So for the sample mean, when it comes to means and samples, we got sample and mean together, we use X bar. Sample and proportion together, we use p hat. Now, notice there's no information here about the population itself, and so that's why we don't have anything defined for those. Okay, so let's change gears here and talk about another aspect of surveys, and that is bias. When we go through and estimate a population parameter using a sample, we perform a survey to collect information from the sample. The method we use to collect the information is very important. A survey method is biased if it has the potential to produce an incorrect result. So what are some types of bias? There's measurement bias. So what is measurement bias? It's when you ask survey questions that mislead or influence the person being surveyed. Now, it doesn't have to be intentional. It can be accidental, but it's still considered measurement bias if you go through and you end up asking survey questions that mislead or influence the person being surveyed. Sampling bias, that's going through and surveying a sample of the population that is not representative of the whole. Right? So if you're going to go through and look at a sample, that sample needs to be representative of the entire population for you to get an outcome that is actually going to be relevant for the population. So if you go through and you survey a subset, a sample of the population that's not representative, then you're not going to get good results. So that's called sampling bias. There's also response bias. The response to the survey from a part of the population that's not representative of the whole. So if you go through and you do a survey, and the way in which you do the survey, so response bias is typically you contact individuals, and then only some of them respond, and you use that for your sample. And so if you contact individuals and only some of them respond, and the ones who respond are not representative of the whole, then that's considered to be response bias. So that happens with cell phone use is an example where we get some response bias, where only certain maybe ideologies go through and respond when they're contacted over cell phones. That's been a topic of discussion in recent years when it comes to going through and doing sampling for political surveys. But yes, response bias is actually a very big deal. All right, so let's look at some examples of each one of these so we can kind of wrap our heads around them. I mean, the definition is kind of self-explanatory, but examples are really good here. So in February 2010, the Albany Times-Union newspaper reported on 2 surveys to determine opinions of New York residents on taxing soda. The Quinnipiac University Polling Institute asked, there is a proposal for an obesity or a fat tax on non-diet sugary soft drinks. Do you support or oppose such a measure? All right, so that was the survey. They asked people, and the results they got were that 40% of respondents said that they supported the tax. All right, so with that language. Another firm went through and asked the following. Please tell me whether you feel the state should take the following step in order to help balance the budget, should seriously consider the step, should consider it only as a last resort, or should definitely not consider taking the step. And the step would be impose a 18% tax on sodas and other soft drinks containing sugar, which would also reduce childhood obesity. When the question was asked this way, 58% of respondents said that they supported the tax. Okay, so the idea of measurement bias is the survey question, is it asked in such a way that it would influence or mislead the individual that's being surveyed? And the answer is that in both of these would actually have measurement bias, assuming the goal is to focus on the tax as far as its effect on obesity. So for the first case, the issue that the aspect that creates the influences the sample or influences the group that's being surveyed would be the fact that they called it a fat tax. That is not appropriate. So if you go through and you do something that influences the audience that you're asking questions of, then that, and using an inflammatory term like that would definitely affect the sample, the people being surveyed. And then as far as this question, note all of this stuff about the budget. If the point of the question is to ask about whether people would approve taxes in order to curb obesity, then all of this stuff about the budget is all kind of besides the point and can definitely influence or confuse the audience. I think I wrote up some of this stuff on here. All right, so and also notice the wide discrepancy. Let's just highlight that 40% when they went through and used this inflammatory term, and then 58% when they went through and wrapped it in a budget perspective. All right, so the wide discrepancy in the results is evidence of measurement bias. Depending upon what was intended to be surveyed, one or both surveys can be considered to have measurement bias. In the first survey, they used the inflammatory term fat tax, which could affect how respondents react. And then in the second, the budgetary aspects of the tax are the focus, as opposed to the goal of using a tax to curb obesity. Okay, so that's measurement bias. Sampling bias. In 1936, Alfred Landon was the Republican candidate for U.S. president running against Franklin Delano Roosevelt. Literary Digest, a popular news magazine, conducted a survey with over 10 million respondents and predicted that Landon would easily win the election with 57% of the vote. Instead, Landon lost big, setting a record at the time for the fewest electoral votes ever received by a major party candidate. What happened? What went wrong? You can stop and think about it if you want to pause the video. Or we just move on. So the Literary Digest relied heavily on polling its readers. Its readers were financially better off than the general public. and were more likely to vote Republican. So that explains why they got a result that was so biased. They only sampled a certain portion of the population that was not representative of the whole. So the outcome was that the reputation of Literary Digest was severely damaged, and 2 years later, the magazine got bought out by Time magazine. More sampling bias examples. So another example of bias are ratings websites. Websites like Amazon, Yelp, or Rotten Tomatoes provide customers with the ability to rate, generally from 1 to 5 stars, their experience with a business or product. The problem is that the submitted ratings are not necessarily representative of the feelings of all customers. People who leave ratings on these ratings websites are often motivated to do so because of strong positive or negative experiences. All right, so what we've got is a sample, right, of the population that's going through and rating it, because not every person goes through and rates it, not every single person. So it's a sample, and the sample that we have are just the people who feel really, really strongly. So the people who loved the product or hated the product, those are the only people that are going onto these websites and rating them. So, whether it's a movie, there's all these passionate, people in favor and against movies, and so they go on to Rotten Tomatoes and they go through and rate the product, or rate the movie. And so the result of that rating is something that you can't take seriously. It is biased, and it's biased because of only a sample of the population that was not representative of the whole was used in determining the results that are on these ratings websites. So the ratings websites may seem great, but unfortunately, you'd need to go through and use a different method for identifying who got to rate the product than the person who felt passionate enough that they went onto the website and submitted a rating. So, okay, so how do we solve this? How do we resolve this problem with sampling bias? So the key to avoiding sampling bias is to use randomness. If every member of the population is equally likely to be included in the sample, then the sample is said to be non-biased. This is easier said than done. Pollsters employ a method called simple random sampling. In simple random samples, subjects from the population are drawn at random and without replacement. Okay, that's an important part. Without replacement means that once a subject is selected for a sample, that subject cannot be selected again. So it's like if you're outside of a movie theater as people are walking out and you're asking them to fill out a survey, you don't survey the same person twice. You survey each person. Well, you survey the people who you can, once each. All right. How can we go through and do a simple random sample? The way in which we conduct a simple random sample is by assigning numbers to every member of the population, and then we use a random number generator to create the sample. So we go through and let's say we've got a sample of people, a population of all these people. We want to do a sample of 1,000 of them. So we go through and we assign a number to every person that's in the population, and we generate 1,000 numbers randomly, and those are the people that are in our survey. In reality, simple random samples they sound great, but they're difficult to collect and they're inefficient for large populations. For example, in most situations, we can't make a list of all the people in the United States and assign each of them a number. And so the simple random sample breaks down immediately. When it comes to going through and doing surveys, other techniques are necessary when it comes to large populations, like all the people in the United States. Now, even if we could go through and assign numbers to every person in the United States, we run into another issue, and that is the non-response bias. So you might go through and you take 1,000 people from all the people in the United States, and you go through and randomly select, and it's purely random. You do a great job. You got a 1,000-person random sample that is representative of all the people in the United States because it was randomly generated. Now, the problem is that when you go to contact them in order to get the information from them, if only some of them respond, then suddenly you've got non-response bias that gets in the way of your survey's effectiveness, right? And so if only certain people or people only with certain ideologies go through and respond, then that can go through and bias your sample. All right, and that actually is a big issue with cell phones. So cell phones, certain, there's, at least supposedly, there's certain certain portions of society that do more screening. There's certain portions that answer cell phones more, and so because of the response rate to cell phones has fallen so dramatically, and we've got that difference across maybe ideologies or parts of society, then just going through and calling up your 1,000 people and just leaving a message on their phone and just say, hey, we want to do a quick survey. If you do it that way, it's unlikely that your survey is going to be very very accurate, because of the fact that only certain types of people will respond to it. Oh, and that is the last slide. So thank you for watching, and I'll see you next time.